Okay, so let's talk about a histogram, what a histogram is and why we use it. Basically, what a histogram does is it takes your data and it groups it together into classes, and then we graph each one of those classes. Now, the reason that we do that is because a lot of times our data is going to contain decimals, and it's going to make a dot plot very difficult for us to actually construct. So let's look at one. All right, so this is what we have here is the points per game for the 30 NBA teams for the 2014-2015 season. And so you can see we've got decimals here, like our Denver Nuggets 101.5, our Miami Heat 94.7. So those decimals are going to make that dot plot really difficult for us to actually construct. So what we're going to do is we're going to create this idea of a histogram. So a histogram is probably the most common graph that we're going to see for our quantitative variables. Remember, those are a number of variables. And what we do is we take our data, we divide it into classes, we find out how many are within each class, and we'll either report that as a frequency or a percent, which is sometimes also called a relative frequency. And then we need to make sure we label and scale all of our axes. Label, label, label. You must do that. Okay, you will not receive full credit for anything if you don't label your axes. Now, the title's not as important, okay? You can get away without leaving the title, but you have to label those axes. All right, so if we took our data, this is what our histogram would look like of our NBA data. So you can see here we've got our PPG, which we know are points per game because we've already defined that in our when we're looking at the table. And you can see here on the side is our frequency here. Okay, so we can see that our classes are running 91 to 94, 94 to 97. So you can say we have a class width of 3. And within the 91 to 94 range, we had 2 of our actual teams. Okay, so we could also make that a relative frequency histogram, and it would look a little bit like this. So we'd have our relative frequency. So we can see here that there's relative frequency here. We can see that our classes did actually not change, but if we notice our values here on the side did. So now we're looking at decimals here. We could have also written this as a percent. Okay, this would have been our 2%, not 20%. Even our 2% because we moved that decimal 2 places. 4% with our and on so on and so forth with our highest being 10%. Okay. So 10% of our teams scored between 97 and 100. Now, when these percentages and these relative frequencies come in play, probably the most important time is when we're trying to make comparisons between two different data sets, especially if the number of individuals within the data sets are different. Then we're going to need to be comparing those percentages instead of an actual count. Here again, you must make sure we label those axes. All right, so when do we want to, we need to make sure we're using these histograms very wisely, make sure we don't make the common mistakes. So what are our common mistakes? Well, first thing, make sure you don't confuse a histogram with a bar graph. A histogram is quantitative data. A bar graph is categorical data, okay? Don't use those counts on that x-axis or percents on the x-axis. That x-axis is always going to be the variable that we're looking at, okay? We already discussed this, but we want to make sure we use percents when we're comparing observations. And just because a graph looks nice does not necessarily mean that you're going to be displaying anything meaningful with it. Show you some ideas of that. All right, so I've got 5 different graphs here. So we can see they're all about the same data set. They were talking about the peak length of our toucan here. So you can see this first graph right here, all right, definitely takes it out and it splits it up way too small. This one here doesn't split it up enough, so the classes are too big. Okay, so and we know that this one here is also not summarized enough. Okay, so what is the golden number of classes that we try to get everything in? There isn't an exact right number, but we generally try to stick somewhere between 5 and 10 to actually make our data kind of grouped nicely. So you can see these two here are probably our best bets. And then from here we would go through and we would actually describe the data. You can see that the data kind of looks approximately mound-shaped, approximately symmetric, okay? Now, don't try to force your data into a particular shape. Your data is what it is. So, just by creating bigger classes, you're not going to always be able to make your data look the way you want it. So don't mess with it. Just describe what you see, okay? So we can see with this one is a bimodal graph. We've got two peaks here. And then in this one, we've got something that's a lot more uniform with one bar here that's not following the general pattern. Okay. So, like I said, histograms are really pretty easy to, construct and to make. And so, we just got to make sure that we read them and that we use them right. And we got to make sure that we label, label, and label.